Wisdom as scientific knowledge requires math, but wisdom as human prudence does not. If we want to know the truth about the world, then we engage in scientific inquiry in which math is needed. But if we want to understand human affairs and make good choices, then math is mostly useless. So the question, how much math is needed for wisdom, is really two questions. One, how much math is needed for science? And two, how much math is needed for prudence? And the answers are respectively lots and none.
Mm-hmm.
I like ecumenical solutions that turn an either or into a both and. The problem I have with the Cartesian and the Cartesian picture is not the distinction of science and prudence, but the claim of their autonomy. I suspect that prudence involves science and science involves prudence. Let me explain. Prudence, for its own purpose of guiding action, must grasp the contours of reality in which we act. So prudence requires knowledge, and such knowledge often seems to require math. Imagine that you are one of the sovereigns of a republic, say an American voter. You want to make a prudent choice about economic policies. To inform your choice, you pick up an economics text and find that to read it, you need to understand linear algebra, multivariate calculus, differential equations, real analysis, probability theory, mathematical statistics, and game theory. Or you want to be prudent about educational policies, so you look at educational research and find it full of matrix algebra, multiple regression, and maximum likelihood models. Can you be prudent, make wise choices, detect fallacies without math? I doubt it. On the other hand, can we mathematize everything, grow clear of our bad beginnings in common sense, and live by clear and distinct mathematical ideas? I doubt that too. Science is a human activity. The scientist must make choices inside and outside science. Is it plausible that all such choices can be treated mathematically? Could, for instance, a mathematician prove mathematically that one should study this topic rather than that? The non-demonstrative dialectical thought that surrounds and directs strict mathematical thinking looks to me like prudence. Mathematizing prudence seems a fantasy. I read a crime thriller in which a character sacrifices chickens and reads their entrails in order to learn the future. When asked whether he really believes in the ritual, he shrugs and says, "I get tired of thinking. The chickens make it easy to know things." When we get tired of thinking, we invent mathematical models, no matter how absurd, to give us the feeling that we know things. As Hermann Weyl, a great mathematician, said, quote, "It's a tragic and strange fact, a superb malice of the Creator, that man's mind is so immensely better suited for handling what is irrelevant than what is relevant to him." So if prudence needs math and math needs prudence, each is involved in the other. So math and prudence are not autonomous, and the figure that the Cartesians and anti-Cartesians share is flawed. What about the Aristotelian picture with its emphasis on causality? My problem is that I don't know how to think about causality. Mathematized nature suggests a causal relation different from the four Aristotelian causes. This mathematized cause relates space-time events. The event that is the cause is, as it were, the input to a mathematical function whose output is the effect. Hence the scientific import of mathematical functions. Now, I cannot believe that if Aristotle were alive today, he would simply reject mathematical physics, though I well believe he would think it incomplete as natural philosophy. My guess is that the advice to learn a little math but don't stress about it underplays math's value even when our main concern is causality. In Plato, the divine Plato, I hesitate about the divided line at least under one interpretation. This interpretation says that as we move down the line from the forms, we get less being, but more beings. Recall the earlier example of the circles. One form, the form circle, generates many mathematical circles, in fact, all the mathematical circles. And each mathematical circle informs many physical things. One circle shapes all same-sized plates. And each physical thing has many images. One plate casts many shadows. Thus, as we reverse direction and go up the line, we successively gather the many into one, and the one has more being than the many. then the mathematicals are fewer but more real than the physical things. I suspect, however, that the mathematicals are greater in number but lesser in being than the physical things. Modern math in its vastness and variety suggests to me that math is part of an infinite realm of possibility from which the actual is selected. Plato sometimes says the intelligible realm is more real than the visible realm. Neither I nor Plato are entirely persuaded. Just as modern physics would give Aristotle pause, so modern mathematics would, I think, give Plato pause. Perhaps a different picture is needed. So, to conclude, how much math is needed for this? I really don't know. In graduate school, I wrote a paper summarizing a contentious field, and at the end of the paper did not take a side in the dispute. The faculty examiner told me that a reader wants a conclusion, wants to know which side to take. I thought, but did not say, oh, so you want me to lie to you so you can feel comfortable? Fat chance! But now I'm old. So I will say this on behalf of enigmatic Platonism. Wisdom, like the good, is one, and like being is two, and like philosophy, is a persistent attempt to see both together. Questions? Comments?
How will we start? Do you think that, I think I know your answer to this, but do you think that an equivalent synonym, an acceptable synonym for mathematics is computational science? If so, why? If not, why not?
What's my answer, Tom?
Is computational science acceptable as an adequate formal description of what is it an acceptable definition of what mathematics is?
I don't know. It's hard for me to think about that. The definition of mathematics I currently like is the deductive study of any abstract structure whatsoever. I think that in actual mathematical practice, I think that this sort of thinking through business which is my translation of the Greek dianoia. It's wonderful. In actual mathematical practice, I think mathematicians spend a lot of time doing dialectical stuff, not just reasoning from consequences. I mean, this is essential, but I think this, and I don't see how that can, I don't see that, this dialectical aspect of actual mathematical practice, trying to figure out, well, what's the best definition? What's the best approach? How should we deal with this? I don't see that as, right now, computational, like which I'm taking as something like algorithmic. So I would say as a practicing discipline, I think mathematics goes beyond the algorithmic right now. Now, I'm not a prophet. People are trying to develop algorithms to generate proofs and all this. I don't know. I'm suspicious, but that's because I'm old. Because I'm insightful.
You're right. Computational science could be a subset of mathematics, but it's not the whole mathematics. And I agree with you. That's a wrong title.
Yeah, I mean, yeah, I'd say, yeah, the